Now, a different view of what might govern the transfer of information into long-term memory was offered by Craig and Tulving in 1972 with the idea of levels of processing. See, they found that the more deeply something had been encoded, the better it would be remembered. Their experiment went more or less like this. They would show participants a list of words, one at a time, and for each word, participants were asked a simple yes/no question. So, for example, you might see this screen. Is the word shown here in uppercase or lowercase? And sometimes it would be uppercase, sometimes it would be lowercase. Or maybe does the word shown here rhyme with a certain other word? And sometimes it would, and sometimes it would not. And the third type of question was, does the word shown here make sense in the following sentence? And sometimes the word would make sense, and sometimes it was not. And see, and after answering these questions, participants would be given an unexpected free recall task, meaning they were asked to just, oh, by the way, tell me as many words that were answers to these questions as you can remember. So this was an unexpected free recall task after having responded to each of these questions. And what you're probably appreciating is that what Craig and Tulving did is that they created a scale in how deeply you have to process the answer word in order to answer the question. Of course, if all you're doing is answering if the word is written in uppercase or lowercase, you don't even have to read it. You just have to look at the lines to tell that. So in this sense, it's a fairly shallow amount of processing that you're doing on that word. At the opposite end, if you have to evaluate whether a word fits well in the context of a given sentence, you have to process it pretty deeply. You have to understand the semantics of the word in order to understand if it fits a given context. And then somewhere in the middle, judging whether a word rhymes or doesn't with another word, you have to at least read it and process its phonetic properties. So this is sort of a scale of different levels in depth of processing. And see, the hypothesis being that the deeper you're processing something, the greater the encoding that happens, and therefore the better the recall at a later time, even if you don't know that you're going to get tested on memory. Remember, participants didn't know they would have had a recall test at the end of these questions. You can almost think at this point of memory a bit as a byproduct of how deeply you're encoding something. So how deep is the mark or the dent that a certain item has left in your mind? And so if you think of it very deeply, the mark, the impression it leaves on your mind is stronger, which makes it more likely that you will be able to recall it. If instead it's literally just a tiny, tiny tick in your mind, like the case of seeing if a word is uppercase or lowercase, then it probably just fades off rapidly, and you don't encode it deeply, so you'll probably forget it rapidly. Now, if you compare the performance, meaning how frequently, what percentage of the words did participants recall, dividing up the words according to whether they were encoded in the context of the case question, the rhyming question, or the sentence question, what they found is that across the board, the deeper the encoding, the greater the chance that you're going to recall a certain word. Now, the level of processing idea that we just saw, of course, emphasizes only the idea of encoding. The greater the encoding, the better the probability of recalling. However, of course, there are other aspects of memory, for example, retrieval and storage. Morris, in 1977, got interested exactly in the role of retrieval in memory. And so he did the following. He took the exact same experiment as Craig and Tulving. So it was the exact same questions, the exact same words that would be the answers, the exact same task. The only difference is that half the participants would do the same free recall task that Craig and Tulving used. So after having answered all these yes, no questions, you'd be asked, oh, by the way, just tell us all the words you remember that were answers to the questions. So for half the participants, they did exactly the same experiment as Craig and Tulving. Now the other half, instead of having a free recall, they had what is known as a cued recall, meaning instead of just saying, hey, tell me all the words you remember, you give them a cue, and that is supposed to help them recall one of the words that they previously studied. So in particular, what they did is they always used as cue the rhyming task. So it didn't matter if you studied a certain word with the rhyming prompt. So does the following word rhyme with the word bat? But for in the cued recall task, you always would recall words prompted by a question about whether a word that you saw rhymed or not with a certain other word. And again, this was, so they would receive this cue both for the words that were studied this way and for the words that were studied, for example, with the sentence context. So in other words, for some words, the cue matched the way in which participants encoded the question, because at encoding, they were also asked about the acoustics of a word. Whereas for other words, it would not match because they studied the word, they encoded the word with a question about its semantics. You know, does the following word make sense in the context of this sentence? So the cued recall was one specific type of cue, and sometimes it matched to the way in which participants learned, and other times it did not. Now, what is interesting is that if you look at the free recall task, so these are the participants that studied just like in the original experiment, and then just as in the original experiment, were asked, all right, now tell us everything, all the words that you remember. Now here, Morris replicated exactly what Tulving and Craig found. Participants who encoded words in the semantic task, so in the having to understand if a certain word fits in a sentence, if it's appropriate for a sentence or not, did better than words that were studied or encoded in the context of just seeing if it rhymes with another word or not. So this replicates exactly the finding by Craig and Tulving. What is interesting is that the participants for whom instead the cue was not free recall, the cue was which word rhymed with the word mat, then here participants did well if they encoded words in the context of studying their sound, of evaluating and processing their sound, but did poorly on the words that instead they encoded in the context of does this word make sense in the following sentence? And see, so and this is an effect that Morris called the transfer appropriate processing. And to here, the idea is that you get increased memory for words that supposedly were processed in a shallow way, just because the way in which you're eliciting a memory matches the way in which you encode it. So in a sense, this effect, this matching between the way in which you encode something and the way in which you cue it and you recall it, highlights the fact that what determines if you remember something or not is not just its encoding and how deeply you encode it, the way that the level of processing theory makes it sound, but it's also about how you cue for something and how you try to recall it. So it doesn't matter if you encoded something, lightly, as in the rhyming task. If I ask you in the right way, you will be able to recall this even better than the sentence the words that you learned in the context of a sentence, because these I prompted them in the wrong way because I asked you about their sound, but you encountered them, and encoded them in the context of their meaning. Now, in fact, Tulving himself studied more the effect of cues on recall, demonstrating that it actually goes well beyond just the sound type cues that Morris used. So here's what they did. They had participants memorize lists of words. And now, without ever overtly telling participants that this was the case, the words came from specific semantic groups. So, for example, some of the words came from the category of birds, some from the category of fruits, some category of utensils. And they were all intermixed among each other. Now, here's the interesting part. If you then ask participants for a free recall, so you give them the sentence and you say, all right, free recall, tell me all the words you remember. Participants end up only remembering just about 40% of the words. On the other hand, if you ask participants to recall them by category, so you say, all right, tell me all the words that were about birds, and blah, 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 you tell them, okay, great. Now tell me all the words that were about fruits, and you blah, 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 remember all of them. If you do it this way, then participants actually do much, much better. In fact, they can recall up to 75% on average of the words that were presented in the list. So again, it's not just that when you're doing free recall, you forgot the other information. It was there. It's just you didn't get the proper cue to pull it out. So these studies really show that the cue that you have in order to recall something plays an extremely important role in your ability to recall it. Now, if you think of it even in a broader sense, things such as context, the context in which you encode something can also be a type of cue. And this is an idea referred to as encoding specificity, the idea that any condition that was present at the time at which you encode something can later help you, if present again at the time you have to recall it, can later help you recall that information with greater ease. Now, Godden and Badley in 1975 tackled this exact point. And what they did is they had participants study lists of words underwater or studying on land. In 1975, that's what you had to do to get a SONA credit for class. So they had people either study lists of words when they were, as I said, on land or underwater. And then they tested their memory either on land or underwater. And the interesting result was that if you learned something on land and then you were tested on land, you did pretty well. If you learned something underwater, but then were tested on land, you didn't quite do as well. And this is, again, this is the encoding specificity effect. Vice versa, if you learned something on land but were tested underwater, you didn't do very well. But if you learned something underwater and you were then tested underwater, you did very well. So this really establishes the idea of context-dependent memory. The idea that there's a benefit for memory when there's a match between the conditions under which you learn something and or encode something and the conditions under which you have to recall something. So in a sense, this is just a conceptual extension of the Morris experiment. But the question is not just how well does a cue tap into the item you've learned. It's actually much broader than that. There are many things that can successfully cue something and help you recall it. And see, this is because when you're prompting, and this can happen, sorry, because you can either you prompt with the same question with which someone encoded an item, or because you prompt, in the semantic manner that we've seen, or because you're just recalling in the same environment, be it underwater, on land. In fact, they've replicated this. If you study in a noisy environment versus a silent environment, then you're better at recalling in an environment that matches. And so you can, in fact, this goes even further. And this extends to your inner state. This is something we typically refer to as state-dependent memory. If you study for something and you're always in a happy or always in a sad mood, you'll do better at testing if you are in the same mood in which you studied. Um, so this again, this really establishes the notion that when there's a matching of conditions between encoding and recall, people tend to perform better. Now, why would this be the case? I mean, why on earth would studying underwater or over water have an effect on your ability to recall? And if you think of it from a network point of view, everything that we encode, we don't just encode, that item and what it means, and that's it. We encode a number of things that get associated with that item. So if you study always, in the same kind of room or in the same way or in the same mood, mood ends up being associated with the things you study. And so can help you in that sense. It's one more thing that can cue and that can prime the things that you've encoded and help you recall them better. Now, there's a number of additional effects. Memory is really just an exceedingly intriguing topic, and there's a number of other effects that have been studied over time that affect how well we seem to be able to recall things. And since there's never enough help in studying for exams, and it's very timely for our class, there are a couple effects that you might find useful to know about. One is known as the spacing effect. And the idea, which I'm sure you're familiar with, much better to learn in a spaced way, meaning having repeated exposures that are spaced over time. So you study a little bit now, then you study it a little bit, a couple days from now, et cetera, et cetera. Far superior to cramming everything, over one night. People just seem to do much better in recalling when they study multiple times overnight, as opposed to all in a short period. In fact, even given the same amount of time studied, if you space it over time, as opposed to putting it all together, people still do better. So even keeping constant how much you have studied. So from this point of view, you might see how it's advantageous to study sort of steadily over time at spaced interval, as opposed to cramming, even if you end up spending more time studying when you cram. And the rule of the thumb, more or less, is that the spacing should be just about 10 to 20% of the time you have up to when you need to recall something. If you're taking an exam in a week, then it makes sense to space information, just about a day or so at most. If you're taking a test in a month, then 3 to 5, 6 days of spacing will probably be the most effective. Second very important effect is known as the testing effect. And this is the finding that when people are asked to retrieve information on their own, rather than just sort of passively being exposed to it or just passively reviewing it, they always end up remembering better. And this is exactly the reason why the book has all these questions throughout, which is why I force you to answer those questions by giving you credit for them. I don't do it because, I enjoy making you answer questions. I force you to answer those questions regardless of how you answer them, because I hope that increased exposure, the fact that you have to try to retrieve a piece of knowledge, that helps you better encode the topics. And it's the exact same reason why I give you quizzes every week. Forcing you to have to retrieve by yourself the information helps you, typically makes people do better on recall, which means on exams. And this is likely because each time you have to recall this information, it just forces you to sort of re-engage it and engage it sort of in an active way, as opposed to just sort of just listening to something multiple times or just reading it multiple times doesn't seem to be as good a strategy.